Welcome all of you to this video. In the previous video, we studied about the circumference and area of the circle. Today, in this video, we will be studying about the concept of the area of a sector of a circle. Here some circles are given. Can you determine the area of all of these? Well done. We find the area of all these circles with the help of the formula of the area of the circle. Let us consider one more circle. If we divide the circle into two parts, what will be its area? Correct. If the circle is divided into two, then it becomes what is called a semicircle, each of whose area can be found with the help of 1 by 2 pi r square. You must remember that the center of the circle has a 360-degree angle. So can you now tell how many degrees will be at the center of a semicircle? Absolutely correct. Half of 360 degrees, that is 180 degrees. Let's move the discussion forward. What do you understand by the shaded part of this circle? Well done. We had studied in the previous class that the part of the circle surrounded by two radii and corresponding arcs is called the sector of that circle. Hence, in this circle, the area OPMQ is minor sector and the remaining circular region is major sector, where PMQ is the minor arc and PLQ is the major arc. So now, can you determine the area of minor sector OPMQ? Come, let's see. Assume in minor sector radius to be r and angle POQ be theta degrees. Now we know that at the center of the circle, the sum of the total angles is 360 degrees, so its degree measure is 360. Hence, the area of the circle can be considered as a sector whose area is pi r square. Similarly, when the degree measure of the angle at the center is 1, the area of the sector is determined to be pi r square upon 360. So can you tell when the angle at the center is theta, what will be the area of the sector? Absolutely correct. The area of the sector OPQ is theta divided by 360 multiplied by pi r square, with which we can determine the area of any sector. If you are now asked to determine the area of the part other than the small sector, that is, the major sector OPLQ of the circle, so can you determine the area? Come, let's see. Observing the figure carefully, we can tell that from the area of the circle pi r square, subtract the area of the minor sector. Then what we get is the area of major sector OPLQ. In this video today, we studied about the concept of the area of a sector of a circle. In the next video, we will see some interesting examples based on this concept. Welcome all of you to this video. In our previous video, we studied the formula of area of a sector of the circle. Today, in this video, we will see some interesting examples based on this concept. Madhu wants to distribute the cake on her birthday among her 6 friends if the diameter of the cake is 12 centimeters. Can you determine what will be the area of each piece of cake? Come, let's try to solve this question. Since according to the question, the cake has to be divided among 6 friends, so we can say that there will be total 6 parts of the cake, that is, 6 sectors will be formed, which we can demonstrate like this. Can you tell what will be the angles subtended by these sectors at the center? Absolutely correct, because we know that the sum of the total angles at the center of a circle is 360 degrees, and we are dividing the cake into 6 sectors, so the angle subtended by each sector at the center would be 60 degrees. Since we have to find the area of each piece of cake, that is, the area of each sector, so for the area formula of the sector, we need the radius. Now by assuming the value as r, we get the radius as 6 from the diameter of the cake. In the above formula, by putting the value of theta and r and solving it, area of the sector is found to be 18.85 square centimeters. And we are dividing the cake into 6 sectors. So, we can say that the area of each piece of cake will be 18.85 square centimeters. Let's look at another example. There is a disc whose radii are 14 centimeters and 7 centimeters, and the angle subtended by both sectors at the center is 30 degrees. So, can you find the area of the shaded part of the circle? Come, let's see. First, let's name the disc according to the given information. Let A1 and A2 be the areas of sector OAB and OPQ respectively. So can you determine the value of A1? Absolutely correct. Put the value of theta and r in the area formula of the sector. On solving, the value of A1 is 51.33 square centimeters. Similarly, the value of A2 is obtained as 12.83 square centimeters. Since we have to find the area of the shaded region, so we subtract the area of A2 from the area of A1, thereby giving the area of the shaded area 38.5 square centimeters. So we can say that the area of shaded part APQB is 38.5 square centimeters. In this video, today we saw some interesting examples based on the sector of the circle. In the next video, we will see what common mistakes occur while solving these types of questions. Welcome all of you to this video. In the previous video, we saw some interesting examples based on the area formula of the sector of a circle. Today, in this video, we will see what common mistakes occur while solving these type of questions. The length of the minute hand of a clock is 10 centimeters. The minute hand moves from 420 to 440 minutes. Can you now find the area covered by the minute hand? Also, find out what will be the area of the remaining portion left on the clock. Here, use the value of pi as 3.14. Pause the video to solve the question and then match your answer. Let's discuss option 1. We know that the angle formed by the minute hand in 1 minute is 6 degrees. And here it says that the minute hand moves 20 mark to 40 minutes, which means that it covers a total of 20 minutes. So the angle made by the minute hand in 20 minutes would be 120 degrees. This diagram shows the minor sector of a circle. By solving for the area of minor sector, putting theta and r in the formula, the area of minor sector obtained as 104.66 square centimeter. We see that apart from minor sector, we have the area of major sector left. Let A be the area of the major sector, to determine the value of which, from the area of the whole circle, the area of minor sector is subtracted. On solving this, the value of A found to be 209.33 square centimeters. Therefore, we can say that the area of major sector will be 209.33 square centimeters. Hence, option 1 is the correct answer. If you have selected option 2, it is a good try. But that is the wrong answer, because when you find the area of the major sector, that is A, then the value of theta is put as 240 instead of 120. Because in place of the minor sector, you considered the remaining angle. And forget that you have to subtract the area of the minor sector from the total area, for which you have to take the value of theta as 120 degrees only. But you did not do that, due to which the value of A derived by you is 104.66 square centimeter, which is incorrect. If you have selected option 3, it is a good try. But this is also the wrong answer. Because since without finding the value of angle of the minor sector as 120 degrees and put the value of angle as 20 degrees in the formula of the area of the sector and solve it further, which gives the incorrect value of the minor sector. And on the basis of that, you also determine the area of major sector, because of which your answer is incorrect. So hopefully you must have understood why the first option is right in this example and why the others are wrong. Teachers can also test the understanding of students in the class with the help of some such examples.